Okay, so it looks like we have not many people showing up today, but we'll start anyway because I want to do at least 3 problems, if not 4, in the 1 hour that we have today. And today is the only time that I'm going to spend handling recursion. Maybe I'll talk about it a little bit on Wednesday, but mostly it's just going to be today. And recursion is a tricky topic to work through because it's so alien to whatever you've seen before. Generally, when you write programs, you can sort of see them in your head. First I'll do this, then I'll do this, and I'll do this. And then the code sort of reflects that step-by-step intuition that you have. But when you're doing recursion, then that intuition tends to break down a little bit, and you have to sit down with pen and paper and think through what the recursive steps are going to look like. And so it's not as intuitive to begin with as solutions by iteration. But it's good to know recursion because in some situations, for example, when you're doing sorting and also when you're doing dynamic programming, trying to do it iteratively is very, very painful, and trying to do it recursively is comparatively much simpler. So there are use cases where recursion is very much a more useful tool than iteration. So in all the examples that we'll look at today, it's possible to find the iterative solution in a very straightforward manner. But the challenge is to try and solve that same problem using recursion. The first one we'll look at is the first easy problem. And here the goal is to print the cumulative sum of some entries in an array. So if these entries were 1, 3, 5, and 7, then the output here should be 4, 9, and 16. So at every step you're printing the sum of all the numbers from that entry to the beginning. So this is the sum of these two, this is the sum of these 3, this is the sum of these 4. So before we start talking about recursion, let's just figure out how we would solve this in general. So let's see, do we need a string? No, we don't need a string here. So let's say we say int main, and we say int array, just budget 100 values. We'll need index, and we'll need the length, and we'll scan the length. This is going to tell us how many inputs there are coming in the array. This is all basic stuff. For I equals 0, I less than n, I plus plus, what do? We scan the array entries. And how do we take the entries? This is good enough, same as array I. And now we have taken all the inputs. If I wanted to solve this using iteration, what would I do? So I want to print the sum. So what I could do is I could say sum, and I could say sum plus equals, just keeping that notation consistent. Oops. this. Actually, let me make a separate for loop for this. Let me make this separate also in some equal to. Okay, now let's compile this. Okay, and let's run it. 4, 1, 2, 3, 4. So you can see that this code works just fine. It prints out the sum. Let me use this example that I put here. 4, 1, 3, 5, 7. It works just fine. I did not use recursion, I used iteration. In general, it is a rule of thumb that you can use, that any problem that you can solve using recursion, you can solve using iteration, and vice versa. So the value of recursion comes because in some cases it's easier to solve problems, or at least it's simpler to state the solution using recursion than using iteration. So before we see such a problem, let's solve this question. We're going to solve this using iteration, using recursion now. So if we are going to solve this using recursion, what do we know? We know that the entry here is the same as the entry here plus this value. So what we can do is we can write a function. Let's say that function is called cumulative sum. Now what are we going to pass into this function? We're going to pass into this function the whole array. We're going to pass into this function the sum, and we're going to pass the size of the array. And then what are we going to do? We're going to say if there is no array left. So what we're going to do is, we have realized that there's a recursive structure here, in the sense that all of these outputs are simply the previous output plus the latest entry in the array. So if the previous output was nothing, then we just have to print the first entry in the array and we are done. If the previous output was this, then we have to print whatever that was plus this. So if there's no array to print, then we just return. That's the base case. Otherwise, what do we print? We print, let's do a space here. The first element of the array. Now, why are we doing this? We're doing this because we're solving this in a recursive fashion, where what we are doing is we are passing increasingly small entries of the array like so. And I'm going to claim that this is going to solve my problem recursively. Now, to some of you this is intuitive, to some of you this is not intuitive. Let me quickly talk through why this is the same solution. Or it's not the same solution, but it's going to work the same, it's going to give you the same answer as before. So what am I doing? If you've read the recursion slides, then you know what's going to happen. Let's say that n was 4 and my entries were 1, 2, 3, 4, right? So what happens at this point in my code, at line 18, I have this array which is 1, 2, 3, 4. And now I will say come sum array, I'll initialize the sum as 0 and I will pass the size as n, which is 4. Now what's going to happen? The first time this function is called from the main function, the array pointer is pointing to the first element in the array, right? All of us know this. If I'm passing array, I'm passing the address of the first entry of the array. I'm passing sum as 0 and I'm passing n as n, which is 4. So n is not 0, so we will not return. What will we do? We will print sum, which is 0, plus the first element in A. What did we pass? We passed A. We passed the first element of the array, so we'll print sum plus the first element in this array that was passed, which is going to be the first element in 1, 2, 3, 4. So we'll print 1. And now we will call another function which happens to be the same function. But what are we doing? We are passing a new array to this function. This is the array 2, 3, 4. So I am saying a plus 1, that address that I got originally, I'm adding 1 to it. So now I'm going to go to the next integer block and I'm going to pass 2, 3, 4, or the address I'm going to pass the address of the second element of the array, and I'm also going to pass the sum as 0 plus the first element, which is 1. So I'm going to pass the sum as 1. And I'm going to pass n minus 1 as n. So n is going to be passed as 3 in this second call to come sum. And then in the third call to come sum, what will be passed? So in the second call, n is still not 0. We will print, what will we print? We will print sum. What was sum? It was sum plus a0. This is what was passed. So 1 was passed. So we'll print 1 plus the first element in the array that is passed. What was the array that was passed? 2, 3, 4. So we'll print 1 plus 2, 3. And then we will pass 3 as sum, and we will pass the third element in the original array, or the address of the third element in the original array, and we'll pass 2. And we'll keep going until we pass n minus 1 as 0, which will be at the fourth recursion. And at that point, this is going to return, and all the functions will return, and the code will exit. That's the idea. Now let's see if I have implemented this correctly. I know I have, because I practiced this before, but just to make sure. So we'll say 4, 1, 2, 3, 4, and you can see that it works just fine. Let's try it with the other set of entries. 1, 3, 5, 7. You can see that the code works. So we can solve this using recursion. We can solve this using iteration. In this case, it is clearly the case that recursion is less intuitive. It's more complex than iteration. Iteration, we could just solve it instantly. When we solved it using recursion, it was a little bit tricky to think through. But anyway, we got there in the end. Now let's handle a case where the recursive solution is in fact more intuitive and more elegant. Let's solve, no, not this one. Let's solve medium2.txt. This is a standard problem. It's also a standard interview problem, programming interview problem. So everybody has to sort of know this by heart. So what's being asked here is, we'll give a string and you have to print it in reverse using recursion. Now this can be solved using iteration very simply also. You just run a reverse, a decrementing for loop, and you print from back to front. That's possible. Let's see how we will do this using recursion. Well, I've already done it, but let me talk through the code. I'm not going to type it up again. I was just practicing this before I started the session. So this is a piece of code to reverse a string using recursion, and let's quickly walk through it. We are taking the character string as input, and then we are saying this function is going to reverse the string, and it's taking two inputs, the pointer to the beginning of the string and the length of the string. The string length function comes with the string library, as you know. So all the work is happening inside the reverse function here. What is it actually doing? So let's see. This is very short. I mean, the code is very, very small. The base case is when the length is 0, and this will make sense once we actually talk through the next line of code. So what are we doing? We are saying reverse s plus 1, and we are passing in length minus 1. So notice that this print statement is not going to execute yet. What is it going to do? It's going to wait for the call to return, but what is going to happen? So the first time I call reverse from the main function, it is going to call reverse with the pointer to the next element in the character array. And then what is that going to do? It's going to check for whether the length is 0, and it's going to just say reverse s plus 2, and the next entry. So what is happening here is that I am essentially stacking a bunch of calls of this function, and as I am stacking those calls, I am stepping forward in the array one character at a time until I hit length minus length, or essentially each time this is decrementing by 1, so at some point it's going to decrement to 0. That is the point when the string will be, or when the pointer is going to be pointing to the last element in the array, in the string. So when that happens, in that call, which will be the length plus 1th call of the reverse function, it will just return. And once it returns, now I can print, or the length call to the reverse function will finally be able to print something. So if the length of the string is 5, there will be 6 calls to reverse in total, and one of them is going to be the call that, or the last call is going to be the call that has len equals 0, so that's going to return without doing anything. For the other calls, the next call to execute will be the one with len equals 1, and in that case it's going to print the first element in this array, or in the string, but the pointer will actually be pointing to the penultimate entry in the string. The last entry, of course, is a null character. This will be pointing to the penultimate entry, and so the last character in the string will actually be printed now, and then this will also return, and then the function with len equals 2 will return, but before returning it's going to print the first entry in that string where the pointer is to the second last entry in the string, and so on. So if you've gone through the slides, you know that the calls to the recursive function stack, and then they return in reverse order to the order in which they were stacked. We are using that reversal property of the recursion stack to print these strings in reverse. Let's see how this will work. So let me print a string reverse, and you can see that I got the string reversed. So this is a nice interview problem because it allows people to ask you about the concept of recursion in a very simplified form. The function called stack in forward order and they return in reverse order. That is the basic concept of how recursion is implemented, and so you can see that this is a very, very elegant solution. You can do it, you can solve this problem by just printing the character array from back to front using a for loop here. But that's not elegant. This is elegant. I'm using one line of code, and I'm using the property that recursive calls return in reverse order to get this answer. So hopefully that makes sense to you. I will share the solution with you, but this is a problem that you definitely should try to solve by yourself. If you do it, you will understand recursion very well. In fact, I can give you something as a homework, which is build on this code to find whether a string is a palindrome. A palindrome is a string that, when it is reversed, looks the same. One of the most famous palindromes is Abel was I, ere I saw Elba. And you can see that when I reverse it, it is the same. So see if you can find a palindrome detector building on this basic premise. Okay, so I wanted to get through 4 problems and we are making good time. So let's look at the next one. This is another one that I like very much. I don't know if any of you are familiar with Huffman coding, which essentially when you are trying to do compression of a string, one good way to do it is to say, instead of printing 5 zeros followed by 10 ones, you just say there are 5 zeros coming and 10 ones coming, and that is a more compressed representation of the same object or the same string. So here we are trying to do some string compression, so that if multiple characters are identical and adjacent, we print only one of them, like so. So let's see if we can solve this problem using recursion. You will see that the recursive solution in this case is actually more intuitive and in fact shorter than the iterative solution, which will probably take a little bit longer to implement. So let's write the code here. So again, I've already written the code here. I'll walk you guys through it, and then we'll see if it makes sense to you. So here we have the string being input, and now the first character of the string we are printing anyway, because that is never going to be a repeat, so we just print it. And you'll see why when I show you the recursive solution. So I'm calling this function, it's taking compress and s and 1 and s naught as inputs. You might say, well, why are you passing in s and s naught separately? S naught is the same as s. You'll see it's just syntactically cleaner. So this is my compression function. And look at the base case. So as usual, when we are doing recursion, and particularly when you're doing recursion and operating on an array, what's going to happen is that you will use a pointer to elements of the array. You will keep incrementing that pointer as you go through the array in different levels of recursion, and at some point you will hit the end of the array and then you have to return. So this is the base case that is being handled for that, and this I is the index that is going to be incremented on every recursion function call. You already know this because we've talked about two separate problems that were using the same logic. And now let's look at the recursive logic. But before we look at the recursive logic, let's look at this. So the last character that was passed, what was the last character that was passed? The last character that was printed, essentially. So we printed this one, the first character in the string, and we're saying this is the last character or the most recent character that we printed. And now we will say, so notice that I passed 1, not 0 here. So I starts as the second element in the array, not the first. So we say if if s1 is not equal to the last character, then you print it. If it is equal, then you don't print it. If it is not equal to the last character, we print it. And then what do? We set the last character to be the character that we just printed, or even the character that we did not print, but the ith entry in the array. So in one call of the recursive function, we are handling one entry in the array. If it is the same as the previous entry, we don't print it. If it is not, then we print it, and we update the last character that we saw to that ith entry. And then we say, let's pass the string in again, and let's pass I plus 1. So now we are incrementing the counter, and so we will look at the third element of the array, not the second element anymore. And we are passing the last entry that was printed. So this is why we are not passing s0, because this is why we are passing s0 separately, because this last thing that was printed, or the last thing that was encountered, is going to change from recursive call to recursive call, and that's why we want to have it passed separately. So how will this work? We already know how this works, broadly speaking. It's going to keep working through the array from position to position, position 2 to 3 to 4 to 5 to the position which has the same count as string length s, at which point the function will return, and then the previous function will also return, and all the functions in the stack will return. Because the print is happening before the function is the secondary call is made, in this case all the prints will happen in the forward path while the functions are being put on the stack, not while they are being popped. So that's how the compression will work. Let's see if it does actually work. Again, I mean, that's a rhetorical statement. I have already tested these, they do work. So let's say test.exe, let's just pass this thing in. You can see that when I pass that input, the output is as expected. Let me put in something else. And you can see that the string compression is happening exactly as expected. We are seeing all the entries that are repeated tossed, and we have all the unique elements entered in the string. Well, not all the unique elements, but we just have singleton entries for all repetitions. If you had something like A, B, B, A, C, 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 you would see a repeat of A. So it's not that it's printing out unique entries. You can change the code so that it prints out only the unique letters also. I'm giving that also as homework. That's not as easy as this particular code. So go ahead and try it so that this string would return A, B, C, D. See if you can solve that using recursion. So that leaves just one problem for me to solve now. And this one I haven't actually done yet. So we can sort of do this in real time. And obviously that means there may be a bug to fix. So we'll fix it if we encounter such a bug. So in this case, this is a slightly challenging problem, but let's see if we can think through it. Let me get the code for this up and running. Oops. Medium1.c. Okay, let me put in the boilerplate before I start to think. Oops. So what are we doing here? We have this entry. The input is going to be just a number, and that number is going to be, and it's saying the number is going to be less than or equal to 20. And what we need to do is we need to print out all possible n pairs of balanced brackets for a given value of n. So if the input is 1, then we have to say how many possible ways can we print one balanced parenthesis. Or I have one pair of brackets and they have to be balanced. How many ways can they be printed out? Clearly there's just one way to print them out, so this is that. If we have input 2, then clearly there's two possible ways to print them out: independent brackets or nested brackets. So you get the picture. This I've put this problem last because this is the sort of problem where iteration will absolutely not help you. It is possible to find the iterative solution, but the recursive solution is shorter and more intuitive. So let's get started with this, and then we'll talk about what the recursive solution should look like. Let me scan the number, and now what will I do? I have to print parentheses, and the recursive solution is to realize that we have, if you have n inputs, then the way to present the answer is to say we'll handle whatever we were doing for n minus 1 inputs, add a pair of balanced brackets beyond that, and then solve the remaining case. So essentially you put the brackets like this, or you put the brackets how to explain. So you either put the brackets, so this is the, let's say that you have the case for 3. I guess this will make it simpler. You can do it like this, or you can do it like this, or you can do it like this, or you can do it like this. These are the possibilities. So how can you get to these possibilities from input 2? This is how you would understand how to solve this recursively. Input 3, this is what you would get. These are the possible, or these are the possibilities. So for each of the cases for n minus 1, we tack on a balanced pair of brackets at the beginning, we tack on a balanced pair of brackets at the end. We see if they are the same. If they are the same, we print out only one. If they are not the same, then we print out both. That will handle these two cases, this case and this case. And we also put a bracket outside, well, we essentially enclose the entries here in brackets. So actually that brings me to the last bit, or the last possibility, which is this. So we enclose each of the results from the previous entry in a in a bracket. So left bracket here and right bracket here. Left bracket at the beginning, right bracket at the end. Left bracket at the beginning, right bracket at the end. When we do that, then we get this case and this case. When we add the brackets at the end like so, we get this case and this case. When we add the brackets at the beginning, we get this case and this case, and this is repeated, so this is not printed. Similarly, you can see that the same logic applies here. For each of the entries, you tack on the brackets at the end, you tack on the brackets at the beginning, and you enclose the whole thing in brackets. That is how you get the solution for the next step. And the base case is you just print out this. So it's a little bit complicated, but you can see the recursive solution. Now let's see if we can start printing it, and then we will understand how this actually works. So we're not actually going to be returning anything, we're just going to be printing stuff. So let's say void parentheses, and what do we need? So we need an index, because we're going to be doing comparisons in the array, so we need an index. We'll need a counter. We'll need a couple of markers to say whether the bracket is open or closed. And let's see. So let me start by saying we'll have an array. It's a cal array, and let's say it's this size. And now what do? So we essentially have to implement the logic that I just described to you here. So let's begin. If close equals n, then what am I going to do? So essentially what I'm saying is that when the closing bracket occupies the last entry, then I will say print, and I will print the array, and I will move to the next line. Now this is one possibility. If the closing bracket is at the end, in all these cases we have the closing, there's a closing bracket at the end. So all those cases we are going to print. Now what about the other cases? Now those are not as straightforward. Else, let's consider all the cases. If open is greater than close. So what this means is that, what open and close are going to be doing here is they're going to mark the position where I have the last open or close bracket in the string. So if open is greater than close, this means that I have an imbalance. So now I have to fix the imbalance. So what I'll do is I will add to this, I will add to this position in the array a closing bracket. And what else will I do? I will make a recursive call to this function with this position plus 1, and I will keep open the same, but I will say increment close by 1 because I have added one more close for the bracket. Why is this? Oh, not plus, this is IDX, I keep getting that wrong. And why is this too many arguments? Oh, okay, now this works. And this is going to be one case. And what is the second case going to be? The second case is going to be if open is less than n. So if I have not yet exhausted my pool of possibilities, then I will say, so this is going to work when open is less than n, if open is not greater than close. If open is less than n, then we will say at this index you put an opening bracket, and now everybody should be able to see what the logic here is going to be. IDX plus 1 is because we just went one step forward. N stays the same. We added an open bracket. We didn't add a closed bracket. And we're done. Really, this code is actually going to work. I think it's going to work because I tried it yesterday. So let me show you that it works, and then we'll see how it works. Again, I already told you how it works, but we'll see again. Medium 1, let's see. Oh, good. ESC. Let's say 3. Oh. Oh, I haven't actually made the function call in the first place. That's stupid. Okay. Parentheses. And we'll start with the 0th entry. We will pass n, and both open and close are going to start from 0, and we'll say wait for input to terminate. Okay, now let's compile it. Now clear exe2. Okay, so for 2 it works. Let's try it again. 3. Does it work? Yeah, you can see it prints out all the cases that I put up here. So what is going on? Now in this case, if you try to understand this iteratively, you really would be lost. That's why I put this problem at the very end. In all the other cases, you can sort of follow the iterative logic. But now I've shown you a piece of code which is working, but you don't yet know exactly why it's working. So again, let's step through this a couple of times and we will see why it works. So when I say parenthesis and n is 2, let's take that case, the simplest case. So n is 2, okay? And index is 0, open is 0, and close is 0. So close is not equal to n, we keep moving. Open is not greater than close, we keep moving. Open is less than n, so what do? We print, or we into the string, we introduce this index. At index 0 we put the open bracket, okay? And then what do? We call the parentheses function with index equals 1, open equals 1, and close equals 0. So now we have this function called open in the stack. And what happens in that function call? So now the first function call is waiting. It's waiting for the second function call to return. Now the second function call, we agreed that IDX is 1, and open is 1, and close is 0. Close is not equal to n, so we keep going. Then we say, is open greater than close? Yes, open is greater than close. Open is 1, close is 0 in the second function call. So what do? We put in a close bracket. And then what do? We call parentheses, and we are calling it with index equals 2. We're calling it with index equals 2, n is 2, open is 1, because that's what was passed into the second function call, and close is also 1. So now, how many function calls are waiting? The first one is waiting. The second one, that the first one, in the first function call, we added this guy to string, and in the second function call, we added this guy to string. And then in the third function call, where open is 1 and close is 1, we will again reach this portion of the loop, because close is not equal to n and open is not greater than close. So we will again make a opening bracket, and again we will have an IDX. In this case, the IDX is going to be 3, and n and open is going to become the open that is passed to the fourth function call is going to become 2, and close is going to be 1. Now open is greater than close in that fourth function call, so we will add this, and then we will make another call. In this case, close is also going to become 2. In the fifth function call, close is going to be equal to n, so we will print out whatever is inside str right now. So we print it out, and then the function call will return, and then all the other function calls will pop also. Now notice that when you have the second function call open, where you have already opened up this bracket, so from this you are making this call with idx plus 1 and open plus 1, and then you're making this call with open and close plus 1. So the call that you made with open plus 1 was where open is greater than close, and the call that you made with open and close plus 1 was where open is less than close. So the call with open greater than close is going to add this bracket. The call with open less than close is going to add this bracket. So there are going to be these two parallel streams of parentheses calls, and they are going to return, one is going to return this string, the other is going to return this string. So that is how we end up getting all these parentheses in the exact correct order. It is because we are keeping the recursive structure of the problem in mind. Whenever we have an imbalanced string, an imbalanced parentheses, we close it. If open is less than n, or if the number of or if it's possible to open another bracket, we do open another bracket. With these two simple rules, we are able to get all possible combinations of balanced brackets. You can see that for the case of 4, we would have a nightmare even trying to enumerate them all, but the code works just fine. Let's try it with the code works just fine. This would be impossible to enumerate. If you tried to make an iterative solution, you would have a big challenge, and you can do it. It's just going to be challenging. The recursive solution is intuitive, and we are able to get the answer with a very small amount of code. So I will share this also with you. Verify for yourself by stepping through the code the way I just did, that it actually works the way I have described. And with these 4, I think you will have you've covered sort of the gamut of recursive problems from easy. The string reversal is also easy, from easy to hard. On Zoom, I believe we have just two people today. Yeah, I think Raj mentioned this, and I added that possibility, yeah. So if any of you too have questions, ask them now. How many people are watching on YouTube? We have, well, not many people. Again, Shivanshu left a message on YouTube. I'm telling you, if I'm programming, I really won't be paying attention to the comments. You have to sort of speak up on Zoom if you want to attract my attention. So anyway, I said we'd do some recursion, and I said we'd try to do some 4 problems. We've done 4 problems. I will share these solutions on the web page the way I've shared the pointer solutions. And then on Wednesday, we will keep moving forward. We will start talking about structures, and we'll do some problems. We'll also talk a little bit about the theory. It's not enough just to do problems when it comes to linked lists and so on. We also, it's a little bit alien, so we want to talk about how it works. There's some notation that's new. I'll walk you guys through it. So I'll walk you guys through the basics of structures in code when we meet on Wednesday. All right. So I gather there's no questions. then we'll bring today's session to a close, and I will see you guys on Wednesday at noon.